Hi everyone. So let's go ahead and get started. Give me a second, just I'll share my screen. And okay, Lacey, can you confirm you can see my screen?
I saw the squirrel for a minute and okay, there we go. It's up.
All right. Hi everyone, and welcome to this season 3 first meeting of i2X First, or Forum for Implementation of Reliability Standards for Transmission. So just a reminder, if you're new to this forum, that we are recording this first part of the meeting, and then we'll post the recording on our website. We are not recording Q&A in the discussion. So if during the first part of the meeting you don't want to be heard or seen, please keep your camera off and mic off as well. So just first of all, let's jump to the agenda for today's meeting. I'll give some introductions to i2X effort and also some new initiatives at DOE i2X that are happening. And then we'll jump right in and we'll talk about NERC project 2025-05, right through revisions. And then how PRC 29-1 compliance can be assessed using IEEE 2800.2 tools. So we'll hear from Jens Boemer from EPRI. We'll talk about implementation guidance for PRC 29-1 and hear from Tim Taylor from SEIA and Ryan Quint from Elevate Energy Consulting. And then we'll hear developer perspective on everything that's happening with PRC 29 compliance assessment. And you'll hear from Katie Iverson from IAS. So we'll take questions from audience after all these presentations, and you can use Slido to post your questions as we go. And you have instructions on how to use Slido in the chat right now. Event code first1 for the Slido. So just go back to what are the key goals and outcomes on this i2X First initiative. This initiative have been going on now. This is the third season, so third year in the row, and we are facilitating understanding and adoption of new and recently updated standards that are relevant to existing and new interconnecting inverter-based resources. So we talk about all new standards related to IBRs that are coming out. We convene industry stakeholders to enable practical and more harmonized implementation of the standards. And as I mentioned, the presentation portion of the meeting is recorded. The presentation recording and slides will be shared on the website. Additionally, the leadership team is also producing summary of all these meetings where we are capturing recommended best practices, challenges, and gaps requiring future work. So a few words about leadership team for i2X. We have Cynthia Bothwell from Boston Government Services. She's contractor for DOE. Robert Reedy from Lindell Reed, who is contractor for DOE. Will Gorman from Lawrence Berkeley National Lab. Jens Boemer from EPRI. Myself, Julia Matevosyan from ESIG, and Ryan Quint from Elevate Energy Consulting. And so this is the same leadership team that has been on for all 3 seasons of i2X First. Just a brief recap of season 2. In season 1, we focused on just standards themselves and standard language. In season 2, we dived in more details on practical implementation of this new interconnection requirements for IBRs and new standards. And we try to cover the full project life cycle, so through the development of the project, but also post-commissioning after the project become operational. We focused on IEEE 2800 standard and new NERC standards that are coming out right now, following up on FERC Order 901. Some of the key themes of season 2 were standards compliance and conformity assessment, again using this, as I mentioned, IEEE 2800 standard and NERC standards. We also kind of looked into drafts of IEEE 2800.2 as the working group was working on that. We talked about IBR plan design and performance requirements, modeling requirements and best practices, change management and commissioning best practices, reliability standards implementation, and lesson learned. And then concluding season 2, we had a one-day workshop talking about grid forming inverter-based resources and future reliability needs. You can follow all of these recordings and meeting minutes, summaries, and presentations following this link below. And I believe Lacey put it in the chat as well. So all of the materials are posted for season 2 right now. So just to jump on season 3, we'll have less meetings in season 3, recognizing we've been talking about this for 3 years. We'll continue focusing on emerging reliability standards and recommended practices for conformity or compliance assessment, depending on which standard we're talking about. The series will provide deeper dives into some of the NERC standards initiatives and IEEE 2800 2800.2 implementation. So as I mentioned, today's meeting is a deeper dive into PRC 29 implementation because this is a very hot topic right now with the industry. In August, we'll talk about milestone 4 projects. In October, we'll have a hybrid session. We'll be virtually and in person during ESIG Fall workshop, and we'll provide deeper dive into IEEE 2800.2. Hopefully it's published by that time. And then in January, we'll have a session on IEEE 2800 series updates. So IEEE 2800 is not just a fixed document. There are updates happening right now. And so we'll cover that in the coming sessions. You can sign up for season 3 following this link. And it's now in the chat. Also under this link, you'll find materials from the previous meetings of season 3. All right, so just a few words about new initiatives. So apart from this i2X first, which I said have been going on for 3rd year now, we just kicked off a new initiative called i2X Stitch, and Stitch stands for Studies, Tools, and Interconnection Consistency and Harmonization. We'll have 9 meetings in this initiative and facilitate similar format forum to this one, but we'll focus on interconnection studies and study approaches. We'll try to identify opportunities to standardize and harmonize interconnection study methods, identify industry best practices, and discuss any remaining gaps in this focus area. So as I mentioned, we kicked it off already. You have a link to where to sign for these meetings, and I would encourage you to participate if that's something that you're working on. And additionally, we also have this i2X technical assistance hours. The idea is we'll provide technical assistance on all the topics that we talked about in i2X first, specifically. So focusing on adoption and harmonization of interconnection requirements and standards. So we offer this one-on-one sessions with ESIG and Elevate Energy Consulting team. So this is part of the leadership team of i2X first, and you can meet with us one-on-one, and you can sign up under the link below. Just scroll down to the very bottom of the page, and there is a calendar where you can sign up for this one-on-one session, and that one is funded by DOE i2X. All right, so just bring up the agenda again before we switch on to presentations, and the first we'll hear about Project 2025-5, right through revision. So this is a revision to PRC 29 standard, and we'll hear from the standard drafting team on what's proposed in there. And without any further ado, Eugen, I'll pass it over to you. Just follow these rules on the screen, be polite, and but also put your questions in Slido if you have any questions. We encourage you to participate as much as possible. These meetings are supposed to be interactive. So let's go ahead, and Eugen, you can share your screen.
Yeah, Yulia, thank you very much for the introduction. And yeah, we are kind of talking about the implementation, and the first presentation is about the revision of the standard that's supposed to be implemented. Well, that's the way it goes sometimes. So some of you who have been participated in the NERC webinars might have heard some parts of this presentation already. Nevertheless, I would like to go through this, some of kind of slides that you might have already seen, but also present the revisions that have been made to the standard in the working group. So just a quick a reminder about the timeline and what initiated all this initiative. And this all began with the FERC Order 909. And the FERC Order 909 was issued on July 24th, 2025. And this order, it approved the standard PRC 029-1 and also approved the implementation plan for the standard PRC 029. Then the order became effective by August 28, 2025, and the effective date of the PRC 029 is October 1st, 2026. At least in the US, in Canada, the regulations is slightly different. This is also being kind of at the first point, the changes, some of the changes being implemented now by the drafting team is that due to the fact that US and Canada have slightly different regulations, and this needs to be considered accordingly in the standard. Well, with the approval of the FERC, the FERC approval of the PRC 029-1, FERC directed NERC also to submit a modification to the PRC 029, and the submission is to be needs to be done 12 months of the effective date of the FERC rule. That means by August 28, 2026. So in around about 2 months, the new revision needs to be submitted to FERC. Now, the FERC Order 909, it addressed 3 concerns that have been raised by the industry. And the first one is to provide greater clarity on the documentation obligation to support exemptions for legacy IBRs. That means legacy IBRs which might not be able to comply with the PRC 029. You will get an exemption, but the documentation required to get this exemption, more clarification needs to be provided on that. Then the second point is that the concerns raised by the industry that the facilities which are already under development but will not be in service by the effective date of the PRC 029-1, also called long lead items, that these facilities or projects will also might also require some exemptions because they have already started, etc., and no modifications can be made. And the third point was to address the targeted and limited exemptions for the high voltage HVDC DC systems that are connecting remote IBRs. So these were the 3 points that gave the NERC the requirement to provide a new revision of the standard. Now, the working group that's supposed to do the revision of the standard, it received a SAR by the end of January. Some modifications were provided to the SAR by the drafting team, and the modified SAR was approved in February 26. So this is actually where the work of the drafting team has started. So by April 16th, the first revision of the PRC 029-2 was created and then sent for ballot. And we have received quite a few comments, so thank you very much for this. The approval rating was around about 64%, which was below the required 66% for the acceptance, which is, I would say, fine, since a few points came up during the discussion. So the drafting team came to the conclusion that a revision is required anyway. And so, we kind of already anticipated that there's a new revision will need to be sent out with the changes implemented. So that means in this month, a new revision will be sent out for the ballot. So that means the drafting team needs to finish all the work by the beginning of the next week. Then it goes to the NERC process of compliance and legal, etc. So, and then will be sent out for a 20-day formal comment period. And then, if necessary, we will have a 5-day final ballot in July 26, and then to get the board adoption in August 2026, to get the FERC approval then by the end of August. Now, what are the three working items that have been identified by FERC and were then taken by the drafting team to make the revision to the document? So the first was to clarify the exemption documentation to get an exemption from the requirements of 4 in the standard. So first of all, in terms of the documentation, there were actually 2 ways to do it. Either, the drafting team is to provide a list of documents that is considered as acceptable, and but this was a kind of seen a little bit critical because it might be difficult to provide a list which is long enough and catches all the different documents that might be applicable. So this is why the drafting team, instead of providing specific documents, has created documentation categories that will provide the technical evidence for the hardware limitations. So we're 4 different categories have been proposed. And so these are not specific documents, but just different categories that can be used. So first of all, there's equipment vendor documentation of the hardware limitation, written engineering analysis, test results, or operational data experience supported by an engineering analysis. So the idea of these 4 different categories is that if there is a new project and the discussions with the vendor are ongoing, it might be very easy to get a vendor documentation. But if the system is already in operation, well, in some cases, the vendor might not be on the market anymore. Yeah, so it will be very difficult to get any hardware documentation. So this is kind of a different ways to prove it are then proposed. It can be done by a written engineering analysis by a third party, or if the systems are already in operation, operational data with some engineering analysis can also be used for the evidence. And this is kind of a very important to say that this is something which is meant to cover all the different, life cycles of the equipment, either directly at the beginning or even with the systems being in operation for many years. So, and we hope that it gives the industry enough flexibility, to provide the required documents. And we have also implemented the changes to provide it also a little bit more clarification based on the comments made for the first ballot. Now, during the discussion, there was a kind of also a point was raised. What is we say, okay, there is exception and for hardware, some hardware limitations, and one of the term being used is hardware causing the limitation. So the general question was, okay, what is the hardware causing the limitation? So, and the drafting team came up with a note to specify the wording of hardware causing the limitation. Yeah. So, and our understanding is that the hardware is could be considered as an integrated systems of consisting of different components. So, and why is this definition important is that, well, a replacement of one component within this hardware, well, will still well, allow the IBR to use the hardware exemption. So that means if I have a hardware exception given from the IBR and I make small change within this hardware, it does not mean that is the exemption that it cannot be applied anymore. So this is kind of because many concerns came from the industry saying, oh, okay, I mean, I have a hardware exemption, but I need to do some modifications. And what does it mean? Will I lose this exemption? Now, if we're looking kind of, let's say, to make it a bit more clearer, kind of providing two examples. And one example is when we're looking on the wind turbine generator. And for example, we need to do a replacement, either it is planned or it is after a failure. Well, in some cases, if we do the replacement, to replace the hardware with new hardware, which will comply with the PRC 029, might not be possible because such hardware is not available. Okay, and even if the hardware is available, it does not mean that that hardware will be fit into this wind turbine generator due to, for example, mechanical limitations. So that means it is a very important kind of for the drafting team to provide the message and to give the let's say the industry the flexibility to make maintenance and to replace the fault components without the need to comply with the PRC 029 standard, which is that might be difficult for the existing equipment. Now, if we're looking now on the plant level and assuming we have let's say 100 wind turbine generators, and one complete wind turbine generator is then replaced. And the new wind turbine generator, well, it will comply with the PRC 029. Well, this is good. I mean, and this is what is supposed to be done. But if we're looking on the plant level and we consider that the plant level has an exemption, that means that if we are replacing one wind turbine generator, which is then considered as a component or a subcomponent. In that case, the plant will still keep the exemption. That means even if the one wind turbine generator is now capable to comply with the PRC 029 on the plant level, the exemption can still be applied. And this was a kind of with this note, this clarification should have been provided to give the industry more flexibility and and to give also more certainty that exemption can be still applied even after a few hardware modifications have been made. And then this second point, which was raised by FERC, is to provide exemption for projects which are under active development and which is the projects, as we also call the long lead items. Now, there is that new inverter-based resources that will be in service after the effective date of the PRC 029 will need to comply with the PRC 029 standard. But as already mentioned, some of the projects already in the execution it might not be possible to do it anymore because the hardware has been already purchased or in some cases already installed, so that this kind of the fulfillment of this requirement is hardly possible. So the team came up with two criteria which will allow the existing projects to go in service without complying with the PRC 029. So, and the criteria to be fulfilled to get an exemptions are, first of all, that for this particular project, an executed interconnection agreement effective date of PRC 029. In the US, it means by October 1st, 2026. And the second one is then executed equipment procurement contract for hardware closing delimitation. Prior, and this is the definition, prior to the first day of the first month following FERC effective date PRC 029, which again in the US will be then September 1st, 2025. So, and this is kind of these criteria have been created to follow the FERC directive to keep the allowable exemption very limited in scope. So, and the idea is that, okay, if we have a specific project under execution, and this project, you know, it has everything in the connection agreement, it has the hardware being procured for this specific project, well, then we don't want to stop this project to be connected, even if it's not kind of fulfilling the PRC 029. Now, during the discussions that we had, especially with the compliance team and the legal team, well, there was a kind of a question raised, what does it mean in service? So at this term in service, it was not introduced by the drafting team of this revision, but it was already in the PRC 029-1. Well, and I would say the drafting team and the compliance team, well, they had some different, let's say, interpretations of the in-service date. And so the clarification was made to the in-service definition, and it wasn't done in the footnote 10, saying, well, the in-service date has the same meaning as the FERC pro forma LGIA. So LGIA, Lot Generator Interconnection Agreement, well, they have a in-service date definition, which is defines the date to be the one when the facility obtains backfeed power. So that means when the first time the facility is energized, even if it's not generating any power, but is then connected to the grid, then it is then considered to be in service. Well, for the IBRs, this definition, might be not kind of I would say not say correct, but might not be applicable. But nevertheless, it was kind of a very strong intention from the NERC compliance team to keep the same definition among all the NERC standards. They're saying, okay, if we're talking about the in-service date, that we have the same definition in all the standards, which kind of also makes sense. Well, let's say this caused kind of a little bit, inconsistency within the revision, which went out for ballot. So now for the second ballot, the drafting team has decided to keep the in-service definition as it is, so it will not be changed. But what we will change is then saying, okay, how we provide the exemption documentation. So we kind of defined a new reference date for providing the documents for the exception. But we keep the in-service date with this definition in the standard. Now, the third point that had to be addressed by the FERC was the HVDC connected IBRs using DC or AC chopper technology. Just a quick recap. What is the HVDC system and why is it using, in some cases, is it using the choppers? So what we see in the market is that we have HVDC systems that are connecting remote islanded networks to the transmission systems. In some cases, it is offshore wind farms or some, let's say, remote generations, which can be also onshore located. But in this case, it's always kind of an islanded network. So that means the HVDC system decouples the islanded network from the transmission system, well, and therefore from the transmission faults. So that means if the fault has happened, all the islanded IBRs do not see the fault and they continue the operation. So, and what is done in the industry is that instead of, let's say, shutting down the IBRs in the islanded networks, all the energy generated by the islanded network and which cannot be fed into the transmission system is dissipated as heat in the resistors of AC or DC choppers. So, and this approach was selected by the industry to ensure that after the fault clearance, there will be a fast recovery of the power again. So what kind of the industry wanted to prevent is that after a fault, it will take very long for the isolated systems, to come back to operation and they transmit power. So this AC and DC chopper technology was developed. Now, if we're looking on the PRC 029 requirements of the fault right-through, we have definitions on the attachment 1.7, 8, and 9, which defines the fault right-through scenarios. Now, it is very similar to the IEEE 2800, but the problem with these criteria is, as they are written, is that, well, the criteria limits the number of fault right-through cases within a 10-second time period, well, but it does not define the number of these 10-second time periods. So that means a fault scenario can happen every 10 seconds. Yeah. Now, the problem is that if you have a dissipation into some thermal devices, in most cases just, resistors, well, the resistors will not cool down within 10 seconds. So that means the technology that is used right now for the AC and DC chopper by the industry, not just in the US, in the whole world, well, it needs kind of a longer cooling down time, and which will not be compliant then with this requirement. So, and this is kind of based on this industry practice and the available technology. The drafting team came with an exemption for HVDC system utilizing AC or DC choppers. Now, in the first revision that the drafting team has proposed, we're going to receive a few comments back, and thank you very much for the industry at this point, because we have received some very, very, let's say, extensive comments describing what the kind of, let's say, the critical points. And I think and it was not intended by the drafting team, but the impression was raised, that the VSC HVDC systems don't need to be compliant with these requirements given in the 0.7, 8, and 9. Well, which was not the case, which is not the case, and was also not the intention of the drafting team. So the drafting team now came up with a new definition, but saying yes, also VSC HVDC systems utilizing AC or DC choppers need to comply with the requirements even 7, 8, and 9, but only up to the capability of the choppers installed. So there is also a suggestion of the chopper design. That means 2 seconds of the rated power of the VSC HVDC system. And these are 2 seconds. That is what is widely used by the industry. And also saying, okay, that this capability needs to be documented accordingly so that everybody is aware of those limitations. And then the coordination with the responsible body authorities should be initiated to kind of to check if there's a limitation are acceptable or certain other scenarios needs to be considered, which might extend the rating, the full duration, and therefore the rating of the chopper. Now, it just kind of having looking on all this kind of the developments or project development in the US. So with this exemption, the only a very limited scope of VSC HVDC systems is actually will be affected. So that means will not place a risk on the reliability of the park power system. So if we're looking on all the HVDC systems right now under construction or under operation in North America, we have only 2 connections that will be affected by this exemption. So it's not a lot, considering all the HVDC systems that are in operation or being under construction. So, and this is as already mentioned, the transmission planners, owners, and operators, and are invited to or encouraged to cooperate with the generator owner to generally agreed on design and the performance for this connection, and then therefore the definition of the chopper requirements. So, and that's it from the drafting team. So as already mentioned, we are now implementing the comments that we received in our first ballot, and looking forward to send out the second ballot, and hopefully that we clarified all the concern, the questions, and that have been raised by the industry, and also implemented the suggestions that have been provided, and and hope that we will be able to fulfill the timeline, submit the document by the end of August, and then ideally that the PRC 029-2 will become effective prior to at the same date at the PRC 029-1, so that actually all the industry will need to apply the PRC 029-2 directly, and which hopefully provides more clarification and for the industry. All right, that's it from my side. Thank you very much, and we're going to have the discussion then by the end of the presentations. Thank you.
Thanks so much, Eugen. And yes, please use Slido to post your questions to PRC 29-2 draft and the presentations that will follow. And now we are moving on to the next presentation, which is by Jens Boemer and Jose Cordova from EPRI, and they'll talk about how PRC 29-1 compliance can be assessed using some of the tools that are offered by IEEE 2800-2. Go ahead, Jens.
Thank you so much, Julia. Thank you so much, Eugen, for the presentation. I think a lot of moving targets to follow, but good direction towards more harmonization, which I think can be valuable to everyone. So we have the privilege here to talk a little bit about how PRC 29 compliance can be assessed using IEEE 2800.2, and I added procedures and tools. So just to start out with, IEEE 2800.2 -2026 is a recommended practice developed by the IEEE that aims to harmonize test and verification procedures for conformity assessment for inverter-based resources. So that includes large solar, wind storage, and also the IBRs connected via the VSC HVDC. The working group that developed this practice has about 170 working group members. It's now technically the same working group that developed the IEEE 2800 and is currently revising that IEEE 2800 and also developing a grid forming recommended practice. This is a consensus-based document, so it is inclusive, and it provides some guidance, and it passed several voting stages, including the Standards Association ballot with about 231 balloters, and it received more than 90% approval. We expected it to be published by now. There had been a small delay, and we are hoping that it will be published this month. The idea is really that this document can help create a technical foundation that enables a paradigm shift towards conformity assessment of inverter-based resources. Many of you have seen these flowcharts before, so I just want to locate the scope of this presentation. And we will be talking about details related to the IBR plant design evaluation, and also mention the as-built installation evaluation that verifies the actual equipment and configuration and control settings in the field. But first things first, question of course is how similar are the rights requirements in PRC 29 and IEEE 2800, because only if they are similar enough, it makes even sense to consider using IEEE 2800.2 as a support for compliance with PRC 29. So this was presented back in March last year by my former colleague Manish Patel at the i2X workshop, and covered the voltage and frequency right through in good technical detail. It also highlighted some of the differences between the standards, and we'll mention some of this today too. But overall, PRC 29 establishes rights requirements that are quite similar to IEEE 2800. So this slide shows how voluntary IBR standards can support with the implementation of mandatory IBR standards like PRC 29. It's a little bit of a busy slide, but the main takeaway here is that IEEE 2800 and .2 can support various IBR NERC standards, including PRC 29, but also PRC 28, Mod 26, PRC 30, and maybe the FAC 1 and FAC 2 standards. So today we'll focus on PRC 29. And these red boxes try to do a little bit of mapping. So there are parts in IEEE 2800, the base standard, related to capability and performance requirements, particularly in Clause 7, that relate to write-through, and the test and verification requirements in Clause 12 are then further detailed in IEEE 2800.2. And in particular, the Clause 7 for IBR plant design evaluation. So to some extent, IEEE 2800 and 2800.2 could serve as a reference or technical inspiration for entities adopting these procedures, including IBR facility interconnection requirements and IBR modeling guidelines for performance verification tests by ISOs, RTOs, and other TOs. So we will not have time to go through all these details. The next 6 slides or so are tables like this one, where we map the NERC requirement from PRC 29 on the left side, then link this to the applicable test that is included in IEEE 2800.2, then reminders of the criteria for the verification, which often come from IEEE 2800 itself. And for the purpose of our review of tools, we choose to highlight which of these requirements and procedures can be automated by EPRI's IBR conformity assessment module. Now, there will be other tools emerging or already available. So this is just one example for our independent EPRI tool. So in general, for requirement 1, which is both about design and operation, of the IBR to meet the write-through requirements. The IEEE 2800.2 framework provides tables that test for balanced low voltage disturbance, for unbalanced low voltage disturbance, and for balanced high voltage disturbance. And IEEE 2800 clause 7.2.2 has the specific requirements. So all of that is supported in the EPRI tool and probably some other tools as well. Now there are exceptions to this requirement to clear fault, for example, and that's an exception that is currently not supported by our tool. Also, any hardware voltage being outside of the hardware limits, if there is a hardware limit that is smaller than the write-through curves and the protection systems are not adequately represented in the models, then that would not be caught by our tool. That might require some review of documentation, but anything included in the model itself can be assessed by the tool and would then show some tripping and non-conformity. Now, the exception of the instantaneous positive sequence phase angle shift that is supported, that is also related to specific tests in .2 for positive sequence voltage phase angle change right through. But then PRC 29 has a specific limit for the volt per hertz exception, whereas IEEE 2800 recognizes that potential capability limit, but does not specify a definite volt per hertz limit. So that is currently not supported in our tool, but as IEEE 2800 will be revised and that limit might be included in the next revision, more specifically similar to PRC 29, that certainly can be included using a timer. Now, sometimes there are discussions about how to interpret the design requirement in PRC 29 and whether that includes as built installation evaluation or the verification of settings in the field. It certainly does not explicitly include that based on the reading, our reading of measure 1 in PRC 29, but we wanted to highlight that measure 1 does include these words but are not limited to, so that in addition to the design evaluation reports that are based on dynamic simulations, studies, plant protection settings review, and control settings design evaluation and review, we suggest that following the full set of IEEE 2800.2 procedures that does include clause 8 as built installation evaluations, a more thorough assessment of the design of a IBR plant with regard to PRC 29 can be achieved. And in terms of operation, measure 1 requires to demonstrate that the operation adhered to the write-through requirements, including any tripping, meeting some of the exceptions that the standard had specified. In that case, the language from 2800.2 related to post-commissioning monitoring in clause 11 that also provides guidance to selection of event triggers and capturing event data can help. And it includes a clause 11.5, which is IBR plan conformity reassessment. So if any event is caught and an unexpected behavior is observed, then this subclause can help reassess the conformity with IEEE 2800 and therefore, to a large extent, also PRC 29. Also, I want to highlight that IEEE 2800 and .2 include periodic test and periodic verification guidance. Now we can go through the next few slides even more quickly. This is the overview on the continuous operation region and our mapping with the applicable tables. There are some requirements in PRC 29 that EPRI had called out as to some extent problematic, given that there are expectations for active and reactive power adjustments during the continuous operation region based on frequency and voltage control. You can read those after the fact. Now, for the mandatory operation region, it's important to highlight that the PRC 29 standard requires the inverter-based resource to exchange current in a certain manner, whereas IEEE 2800 requires the IBR unit to inject reactive current in addition to the pre-fault current, both in negative and positive sequence. So IEEE 2800 is very detailed in that regard, and all of these details can be assessed with IEEE 2800.2 tests and the EPRI IBR conformity module. For the permissive operation region, which is the region where it is allowed for the IBR plant to enter momentary cessation or current blocking, those criteria are also specified in IEEE 2800 context, and the EPRI conformity assessment module can assess all of those. And for the restore of real power output requirement in PRC 29, that also relates to requirements in 2800 and the tests included in 2800.2, as well as the automation of those tests in the EPRI module are shown here. And last but not least, the frequency write-through, which is specified in requirement 3 of PRC 29, has a corresponding requirement in IEEE 2800, and the .2 tests are specified to assess the response of the plant for small frequency deviations. But it's important to highlight that .2 decided not to include tests that test the frequency write-through capability all the way up to the edges of the frequency write-through curve. This is actually done by a review of the IBR plant design documentation and OEM unit documentation. So therefore, this requirement is not supported by the EPRI IBR CA module at this point, but it is something that future releases can still include as industry may consider a need for that. So to summarize that part, most of the requirements can be mapped to the requirements in IEEE 2800. PRC 29 leaves out some important details that 2800 and .2 flesh out in further detail. The IEEE 2800 framework can support closing some of the technical gaps, and tools like EPRI's IBR conformity assessment module may be utilized. Now, looking at these tools a little bit more in detail, you can access it if you are an EPRI member of one of our research programs at this link. And the tool is independent of whether you use model or measurement performance. It can be used for either. And it can also be used to assess whether a IBR unit is compatible. So not only the IBR plant. If you are interested in providing feedback or learn more about the tool and related requirements and procedures, we have a Applications of IBR Standards Collaborative Forum, where we also collect feedback that continuously improve this software. The test included in that can be assessed by the tool, and also how these tests are mapped to specific PRC 29 requirements is shown here on the slide. And additional tests can go beyond that and will be added in future. But now I wanted to end my presentation with a question, and that is, do we really need all of this fancy modeling? And is this the only way to manage risk in terms of assessing rights through compliance? As you know, many of the rights through compliance depends on the capability and the performance of the IBR units. And of course, there are important parts within the collector system and the plant that needs to be verified, including protection. But other areas also manage risk by developing databases that include component certificates that are compatible or compliant with requirements specified in standards. And one of these examples is a database from Germany, the Central Register for Unit and Component Certificates, which has more than 2,000 certificates for 13,000 different units. And these certificates can be retrieved by interesting parties. So you can go there to this link and also register and access the information. And in the case of IEEE 2800, at least, many of the requirements are actually quite similar to the requirements of the standards for which this database certifies equipment. So one question is whether in a risk management scheme, this approach can also add some value. Maybe not necessarily this particular database, because this is a German database, but maybe something like this could add value also in North America. And as I said before, if you're interested, you can reach out to me and explore access to this IBR conformity assessment module, as well as get in touch if you're interested in joining our application of IBR standards collaborative forum. And Julia, thank you so much for the platform, and back to you.
Thank you, Jens. Again, I encourage you to post questions on Slido with event code FIRST1 as a code. And we'll continue the topic of implementation guidance of PRC 29-1. And we'll switch gears to Tim and Ryan. Go ahead.
Yep. Thank you, Julia. This is Tim Taylor. I'm with SEIA, and our topic is implementation guidance. And this is a good follow-up to some of the things that Jens was just talking about in terms of how we can all learn how to implement PRC 29 in a better way. So next slide, Ryan, please. So SEIA may not be recognized by everyone on the call here. So just a quick intro, we're a trade organization for solar and storage. Although some of our members do have, they do have wind, but we've got 1,200 members, and they, you know, they range from manufacturers all the way down through developers, EPCs, service providers, and even generation owners. And you'll find SEIA particularly on state and federal legislation matters. Now, I happen to be an engineer in SEIA, so I am supporting those folks that are running out to the state capitals or to Washington, D.C. And in particular, I'm focused on regulatory parts, such as NERC and other regulations that are pertaining to IBRs. Next slide there, Ryan. So implementation guidance. This is a NERC program, may not be widely recognized by everyone. So just to give you a description of it, it's a neat program developed by industry and for industry, meaning that anytime that someone has implemented a standard or a portion of a standard, they can share their experience through the NERC implementation guidance program. Okay, so it's a way of sharing knowledge among the different participants in the industry. So really serving to kind of elevate the industry. So it is, when guidance is developed saying, okay, this is how you implement PRC 29, or this is an example of how you can implement PRC 29, it's got to be vetted and submitted through a pre-qualified organization, meaning that the organization has gone through a little bit of a NERC education, if you will, on what makes good implementation guidance. And SEIA became a pre-qualified organization at the beginning of this year. And if you're interested in doing so, you can be a pre-qualified organization through the Compliance and Certification Committee at NERC. So implementation guidance is examples or approaches to illustrate how the registered entities could implement a reliability standard, but let's be clear, it's not the only approach, number one. And number two, if you follow the approach, it does not guarantee that NERC says that you're in compliance. It just means that the CMEP activities, that they will give a deference to the registered entity when they are auditing or overseeing how the registered entity has implemented the compliance or implemented their program of compliance. So there's no guarantees. However, as Ryan will get to in just a bit, it's a very good way of ensuring, or I shouldn't say ensuring, but of improving your understanding of how to comply. And we'll put this link in the chat, but the link that was on that slide, we'll put it in the chat. And that's where NERC keeps all of the implementation guidance on different standards that have been developed. Okay, next slide there, Ryan. 29, developed, we put together a task force. SEIA, some of the SEIA members, and we brought in Elevate Energy. So we decided to do implementation guidance for 29-1 due to really the technical complexity of the ride-through evaluations, as Ryan will explain in just a second, as well as the urgency of spreading the knowledge with these compliance states that we have that are staring us in the face. Now, these compliance states are only for design. They are not for the operations part. And we are not addressing requirement 4. As Eugen had described at the beginning of our webinar here, requirement 4 is under extensive revision and will be balloted once again just within the next couple of weeks. So we did not cover R4 and focused on design elements and not operation. With that, Ryan, I will turn it over to you. Thank you.
Awesome. Yeah, thanks, Tim. Hi, everyone. Ryan Quint with Elevate. Yeah, just going to continue on with what Tim was describing in terms of the draft implementation guidance and just give a quick overview and rundown of what's in the document. It's still currently in draft. It's under review by the ERO Enterprise team. And so everything we're presenting here is draft. We're hopeful that we'll get a positive outcome, but we will see. But regardless, we wanted to share the technical details of the guidance document here to help elevate industry understanding and the practices that are being implemented regarding compliance approach. So as Tim mentioned, this is intended to be a highly practical, pragmatic, usable approach for what is a PRC 29 IBR design, ride-through design evaluation, right? There's a lot of discussion. Jens covered a lot of great content regarding .2 and practices there and various tools, etc. But ultimately we, Tim and the SEIA team and us said, okay, well, let's just put it out there. What we believe is one viable, technically rigorous, sound, a detailed engineering approach on how a comprehensive ride-through design evaluation is completed. It includes the desktop evaluation activities. It includes simulations. It includes various ways in which you can assess the different requirements and sub-requirements and technical items of the standard. And all of that is captured in this document. So like Tim said, you can go to the implementation guidance website. It's posted there. You can download the draft. You can take a look at the draft, and hopefully it gets moved to the permanent place. And as Tim mentioned, we're focused on -1 since that's what's published and current, under effect. When -2 comes out, we'll do a quick revision. We didn't focus on R4, which is where all the edits are being made. And so we have kind of a quick, easy way to update the document and stay aligned with the standard as it goes through its modifications. So at a high level, the evaluation, and this has been presented, I think, before in other venues, including ESIG, but there's really 6 steps to the evaluation that we've put forth in the implementation guidance document. And then there's sort of that lingering 7th step, which we didn't cover in detail, but that's compiling evidence and tracking and retaining documentation, that kind of thing. But I want to go through quickly here the 6 steps. So the first one is, and then we'll go through each of these quickly in more detail, and the document provides a lot more detail than this. So the first step is, gathering all the site information of what's out there actually in the field, the ASLEF settings, ASLEF site data. Then very likely there's this sort of coordination with the manufacturers that needs to and often has to take place through the whole process, really. But making sure we have a good understanding of what's in the field, what are the max capabilities, what are the settings. Sometimes some entities require much more engagement with the OEM than others, some technologies, etc. So that kind of pervades throughout. Then you have the step 3 is the protection and control setting verification step. This is focused really purely on what's out in the field. What are the protection settings? What are the control settings? What are the balance of plant relay settings? And making sure that is well understood and evaluated very thoroughly, but really before we touch any models. Then once we've got a very good understanding of what's out there in the field, we verify, the models that are being used to conduct some simulations, which in my personal opinion, I believe is sort of an add-on to step 3 and is not a replacement of the detailed verification that happens. But we make sure we have good models. And then step 5 is we run a set of crafted simulations that are testing the requirements and sub-requirements of the standard in specific ways. So focused on permissive region, mandatory region, continuous region, reactive power contribution, looking at momentary cessation, looking at all those sub-requirements, making sure that some of the things that can't be captured with the step 3 efforts, the protection and control verification, are evaluated with the dynamic simulations, the ride-through simulations. Then we can look at what passes, what fails from a standard perspective, from the requirements perspective. And we can look at, well, what changes need to happen, what corrective actions need to be put into place. Maybe it's, moving the balance of plant relay settings. Maybe it's modifying the control parameters, tuning of the controls. Maybe it's adjusting the IBR unit capability settings, those types of things. All of that gets evaluated, and often there's sort of an iterative approach to go back to certain steps, update, and then drive forward a design evaluation that complies with the standard, or where possible, exemptions may be needed for the previously in service equipment. So just looking at what are the outcomes and what are we trying to do here? Really, there's kind of 3 outcomes. You either have a compliant IBR plant design, the plant as I'm going to focus on sites that are existing in service equipment, right? So the stuff that's out there in the field is compliant, and really it's do the evaluation, compile the evidence, retain that, be prepared for compliance audits, those types of things. Or you have software-based updates that are needed, which could be a slew of things like I mentioned, the ride-through settings changes, protection setting changes, controller setting changes at the IBR units. Maybe the PPC controls need some adjustments. Maybe the balance of plant relay settings need to be changed. Those types of things, right? And that appears based on, early experiences is quite common. And then so that's going to have a slew of updates or actions that need to take place, right? Update models, coordinate plant personnel to make changes, coordinate with the TP, the transmission planner and planning coordinator regarding, FACT 2 qualified change criteria, engage with a qualified protection engineer organization. So lots of things that have to take place when changes at the site have to occur. And it's really dependent on the types of changes that are needed. You may have to reconduct mod testing. You may have to reconduct PRC 19 protection coordination studies. You may have to update your models. Or you have a hardware-based limitation. And in some cases, you can have multiple of these outcomes. A portion of the plant may have a hardware-based limitation. Another portion of the plant may have relay settings that need to be modified. So these are not mutually exclusive here. But in those cases, then you're going to be seeking to prepare documentation and evidence in accordance with requirement 4 regarding those exemptions. So the guidance document on the first step really just kind of covers the various types of data that are needed when you're doing an evaluation. And we've really broken it down into the required information that we feel is sort of absolutely necessary to be able to complete an evaluation. And then there's helpful data, or helpful information that in some cases, especially for older plants, may be hard to track down in some cases. But when we can get our hands on these things, they're quite useful and help us kind of corroborate that the other pieces of information are accurate. And so we collect all of this information across the whole plant as sort of step 1. Then we sort of evaluate what we have, what we don't have, and particularly focused on the IBR units and the power plant controller. There are certain things where we feel we may need to engage with the manufacturer of those equipment. Some settings may be hard-coded. A lot of the OEMs will often have a technical memo or an application guide or some type of information that they're providing to their customers to say, hey, here's a breakdown of all of our turbine makes and models and the evaluation that we've completed as a manufacturer on how we feel that piece of equipment supports or helps meet compliance or does not meet compliance with the standard. And in the through all of these standards efforts, including PRC 29, including NOGR 245, et cetera, those documents evolve, right? Because as we start digging into those documents, we realize that there may be misinterpretations. So we'll get a document, for example, from an OEM that says, well, you must purchase this piece of equipment to comply with the standard. That's not what the standard says. The standard actually says I don't need to purchase that piece of equipment because it's a hardware-based limitation. So there is quite a bit of back and forth that goes on with the OEMs to say, hey, we need this updated so we can actually use it for compliance evidence, because right now it hurts more than helps. That happens quite regularly, and that effective collaborative communication with the OEMs is absolutely critical through the whole process, because you don't want to compile a compliance package that's missing that core OEM evidence that all the other asset owners have, right? So you have to engage with the OEM. And the more you can kind of provide a clear checklist of the things that are needed and the list of questions that you have, the more likely you are to get a good answer from the OEMs. Then we move into step 3. We've got the data we need, we've got the OEM information, we've got the site information, then we start evaluating the different pieces of the puzzle, right? So typically we start with the IBR units, we look at the ASLIF settings, voltage ride-through settings, make sure that the curves match expectations. Now we're not just doing a curve matching on voltage, but we found it's very helpful to plot those things, right? Because somebody's always going to ask, well, what's that versus that? So having a visual of the different curves just to understand where they fall is very useful. But we believe you really should be validating that, verifying that with a simulation to prove that, for a ride-through curve at the point of measurement, the settings that I have at the turbines are, adequate or suitable to ride through. But then there's all the other clauses, right? Instantaneous over voltage, and what the trip settings on those types of things are. There's the instantaneous trip settings based on instantaneously calculated voltage measurements with a filter length less than 1 cycle. These are the gotchas that often, again, require OEM engagement, because you're not going to typically find in their documentation, well, what's your filtering for your voltage measurements used in protection? So we have to ask these types of questions usually. And we've got frequency ride through on the units, right? There's a measurement window. There's the curves themselves. There's a don't use instantaneous or single points of frequency measurement. All these clauses or items in the standard we have to make sure we've addressed. And often what we're seeking is, well, what's the max capability of the specific turbine or inverter we're working with? Because we'll likely need that, especially if that existing site doesn't comply with the standard. Well, the next logical step is, well, how far can we push it out? Well, we need to know what the capability is to know how far we can push it out. So we need to know those things. And then there's the Rokoff and consecutive voltage ride through capability that typically is a statement or some documentation coming from the OEM. Again, it's in some documents, it's not in other documents, kind of depends OEM by OEM. Then there's the control modes, the fault ride through modes, current blocking / momentary cessation, reactive current versus active current priority, reactive power versus active power priority, and the continuous operation region, fault current injection, negative sequence current injection, PPC settings, gains, time constants, deadbands, reactive power voltage control, active power frequency control. Very rarely the PPC will have protections, but occasionally we've seen it, and so we check that just to be safe. So again, we're just checking to make sure all of these things are set appropriately. Some of these are direct reflections of the standard, where actually, one of these bullets links to a specific sub-requirement. But in a lot of cases, it's just understanding the plant, make that, so that way we can do a model verification, make sure the model is reflective of this. And then the relays and the balance of plant, the collector system, medium voltage bus, high voltage side, any shunt devices or dynamic reactive devices. We're looking at voltage, frequency. There's a exception for volts per hertz relay at the high side of the MPT. And again, checking the filtering, instantaneous trips, those types of things to make sure that all the curves are in alignment and compliant with the standard. So once we do all of that, then we move into the model space. Really, the first step is just doing a basic model verification. Is the plant configured the same? Is the IBI units configured reasonably to reflect what we know is to be at the site? Is the PPC set accordingly? And then many of these models don't often have balance of plant relay protections represented. So we're adding those in, and we're mainly focused on voltage and frequency. And actually we're doing frequency, as Jens said, we're not doing that with simulation. So it's really focused on voltage, making sure that we've got, the collector system and high voltage relays represented. So when we run the simulation, we would see a trip if that protection setting were to trip. Right? So we're adding those in to the existing model because usually they don't exist. And a lot of that's actually helping us prep collectively as an industry prep for Mod 26, which has some language around protections being represented in the models. We do call out in the guidance document that model selection and just modeling in general, there's a number of disclaimers that have to be placed on the use of these models. The results are only as accurate and reliable as the accuracy of the models. And there are known modeling and simulation limitations that exist in the tools, particularly in the phasor domain tools. So when you start adding in, shorter duration protections, those things are known to cause spurious tripping, which, I grew up as a transmission planner. You would sort of disable those things in some cases because it's just not realistic. But the simulation, the way that it's coded up and modeled and represented, you can't have all these things tripping when in reality they don't actually trip, right? And so you have to make some reasonable assumptions. And in many cases, in some cases, certain protection and control functions are not even represented in the simulation domains themselves, right? So the standard library models we use don't represent things like the DC bus or the PLL or a lot of the instantaneous voltage protections, those kinds of things. And then even when we jump to the EMT space, we would assume that those models are a whole lot better, but a lot of those things are also not modeled in the EMT models as well. Rokoff protection, phase jump protection, etc. Right? We've had a number of cases where the OEM says, yes, we have this protection enabled. It's set at 5 hertz per second, whatever. Okay, we simulate a 6 hertz per second in PSCAD and we see no tripping. We go back to the OEM and they say, oh, it's not actually represented in the model. Okay, so we can't presume that these models have all these protections in them. We want to check them, but we have to take those models provided by the OEM at face value because they're often black box. We do the best we can, right? So generally what we've said is, especially for legacy sites, you know, all sites are going to have a phasor domain model. Some sites may have an EMT model. Really what we want to use is the most accurate, trusted model available. So we don't give preference to one or the other, and definitely don't necessarily say an EMT model is required. But if you have a verified and ideally validated EMT model, it's generally better than using, say, a standard library phasor domain model. But a lot of the existing sites don't necessarily have that EMT model. They may possibly have that EMT model once Mod 26-2 goes into effect, but that's years from now. And so those models are not, you know, shouldn't be expected to be readily available. And it's very expensive and time consuming to get those models for existing sites, working with the OEMs, etc. So we just have to have some practical balance there, I think. But really the document is saying use the best trusted model that you have that is ready for its intended use. And typically they need work regardless. So once we've done all that, then we can prepare a set of simulation results that, again, are testing certain requirements and sub-requirements of the standard. And we've just listed out here, you know, and again, the implementation guidance is an example. It's not the de facto way that the interpretation of the standard. It's just presenting one option, right? And so we've laid out, for example, a set of tests here as an option, very similar to what I think Eugen showed earlier, that there's a suite of tests, voltage ride-through tests, voltage step tests, fault tests, looking at reactive and active power recovery and responses, consecutive fault test. And then we've got a set of additional tests that we focus on only on the EMT space because the results you're going to get in phasor domain really aren't sufficient, or the phasor domain tools can't represent. And so things like phase angle jump Rokoff, unbalanced fault tests, we're really focusing only in the EMT space. So again, this is one option, but then we link those to, well, what are we actually testing? So in the guidance document, we've got a set of kind of evaluation criteria in terms of, well, what are we looking for in, for example, test one? What are we checking in test one to make sure that we, meet the specific sub requirements as listed, right? And so we kind of make that linkage of, well, here's the test, and then here's how we compare that test or evaluate that test as compared to the standard requirements. And then lastly, which I think is actually the hardest thing by far, is the remediation and corrective actions, right? So you go through the evaluation and you determine, do I have any necessary software-based updates that need to happen, protection changes, control setting changes, possibly some firmware upgrades or configuration changes, balance of plant relay modifications, and you develop it. And then there's sort of this iterative approach, because I have to create this post-modification state to then re-simulate and prove that I passed the tests so that I can prepare my final IBR design evaluation and then get to work implementing that IBR design evaluation before my operational obligations kick in from a compliance perspective, right? So you got to establish that final post-modification IBR design, which is reflective of, here's all the changes, here's where I am now, here's all the changes I'm going to make. And then once I've made all those changes, then I've got a final design evaluation that I'm using from a compliance perspective. And then that defines the corrective actions I need to make to get to that post-modified state, right? Now that it can be a simple exercise, or it can be an extremely complicated exercise. And that's, again, going back to the big, we don't have this necessarily in the document, but just from practical experience, there are a lot of model limitations that we have, right? So we see, hey, the plan is fully compliant, but it's not meeting the 1 second, active power recovery. The documentation from the OEM says it should recover within 1 second. So is it actually compliant, or is it some weird model issue? Because if it's some weird model issue, am I compliant? Because my simulation doesn't prove I'm compliant, even though the OEM says what's out there is compliant. So you run into these complications of, well, what do I trust? What do I use? And now we've just created this, model verification, model validation exercise, where in reality we're just trying to prove that the plant's going to ride through, which all indications show it does, right? So that's where the complications start to show up from a practical perspective, and making sure that all of these corrective actions are laid out in a reasonable, effective way. And the implementation guidance kind of covers those things in detail in terms of a flow or a framework, as we've got bulleted here, in terms of getting to that final state of, identifying the changes, reflecting those in the post-modification design evaluation, and then getting to work implementing those in a coordinated manner. So again, encourage everyone to take a look. We're waiting for, response from the ERO enterprise. They've been very responsive, helpful, and, working us through the process. And, we're aware that the evaluation is underway. They got right to it, which is awesome. Well, of course, as Tim mentioned, we'll address any questions or concerns that come up if applicable. And we're hoping that for a positive outcome, and then plan to, widely share this with industry stakeholders. As Tim mentioned, it's not a guarantee for compliance, but CMEP staff give deference to, entities when they follow the approach laid out in the implementation guidance. And so we see a lot of value in not only helping educate and inform industry on, an effective way to implement the standard, at least in our eyes, but then to be able to have, a piece of evidence that they know they can sort of trust because it's been approved is, generally aligned, I'll say, with the, expectations of the CMAP team, right? So very hopeful we'll hear something in the next couple of weeks. We were, I think overly optimistic, but hopeful we'd hear something by today. But we knew that was a stretch, so it should hopefully be coming pretty soon, and we'll let everyone know. And then, I don't want to speak for Tim, but I think the focus obviously is starting to shift to Mod 26-2. And so there's been quite a bit of discussion on, should we do something similar with Mod 26-2 implementation guidance? And I think things are looking like we're going to try to do something, because there's a lot of industry need in that. We're kind of a little bit more ahead of the ball on that one, which is great, because we've got a couple of years from a compliance implementation perspective. So I think that's all we got. Thanks, Julia.
All right, thanks so much, Ryan. And so then last but not least, we'll go to hear about developer, generator, owner perspective on challenges and solutions with PRC 29 compliance assessment. Go ahead, Katie.
Perfect. Thank you, Julia. Thanks, Ryan. All right, so my name is Katie Iverson. I am a senior manager of generator modeling and power system studies at AES. We are a developer and generator owner in this space. In my previous background, I was involved in event analysis as well as compliance of NERC standards. So at WEC, I reviewed a lot of PRC 24 self-reports and audit findings occasionally. So I have a little background in that to share today. To give an idea of our business portfolio, I think what's really most important to the matters we're talking about today is we have a pretty big fleet of operating assets and assets in development. We have a lot of different manufacturers and a lot of different makes and models of inverters. I think probably around 16 or more different manufacturers. So my background comes from working with a ton of different people in this space. As an overview today, we'll do background and history, clarification, public service announcements that I think is useful to some of you today, ride through documentations and settings. And I think I saw some questions in the Slido. How could we make things better to get documentation we need, how to work with OEMs? I'll have some suggestions here at the end as well. Background and history, I think everybody knows this, but just to bring everybody up to speed really quick, there were lots of disturbances. Generators tripped, made people worried. There were a lot of industry responses. There were NERC alerts. IEEE 2800 was launched. PRC 24 was revised. We got things like NOGR 245, agreement updates, and PRC 29. Now, I made this meme because basically at the time it was ride through or draw 25. and we drew 25, so here we are today. Public service announcements for subject matter experts, just to clear some things up that I see are commonly misunderstood or need to be understood. NERC standards exist for reliability, and a reliable grid is important for your assets. If there's no grid for you to connect to, you're not making money that day. You can damage your equipment. You do want your lights on, and you want your project to be operating. That's in your best interest. So this standard actually exists also for your best interest as a developer. PRC 29 may not be the only ride-through requirement for your asset, especially as we're seeing IEEE 2800 adoption in so many regions. PRC 29 isn't your only ride-through assessment that you probably have to do on future sites. There are requirements in your interconnection agreement. In some not common cases, perhaps in your PPA agreement. And there's also a new NOGR 245 in Texas. So just keep in mind, this isn't your only rodeo you're in. Also, another common misconception, design report settings and other material are stored and provided for enforcement activities. Something I commonly hear is, well, I didn't hear anything back from NERC, so I must be correct in my approach. Your reports and designs and all that stuff is not sent over to NERC when you're done for review. So hearing nothing does not mean you did anything correctly. Okay, so I wanted to talk a lot today about inverters, specifically turbines, ride-through settings, and what we see from manufacturers. I'm not going to go into things about relays or protection systems. My main focus today is on this matter. I want to note that what I see, maximum ride-through settings are provided, or capabilities. Capabilities become settings. The settings recommendations have changed over the years, and there's good reasoning for that, right? Once we see new standards coming out, manufacturers should be looking at their equipment and figuring out, okay, do we comply with this one? What tests do we need to do? I think some of what I see happening that's not the best news, depending on which lens you're looking through, is they've changed, and they haven't changed necessarily for the better. So when revisiting and retesting, I think some manufacturers are saying, you know, maybe we can't actually ride through what we said before, and things are being tightened rather than expanded. That's kind of a big deal for us, and we're working through a lot of, I'm hearing that there's a lot of working through that for many, I would say quite a few manufacturers. The other thing that I see quite often from manufacturers is that the maximum capabilities or settings are not always selected as recommended or default. I can't say for every reason why that is, but a lot of the NERC alerts and recommendations have been, you know, expand this as much as possible. So why those maximum capabilities are not becoming recommended is something for the industry to address. Attachment items also, I think Ryan mentioned, there are a lot of things in the standard beyond just a voltage and frequency ride-through curve. And those are not typically addressed in documentation. Not every single item at the end of PRC 29 is addressed. So tips and recommendations for OEMs first, because I think this is where the majority of interest seems to lie. Like I mentioned before, there's PRC 29, but we also are going to be having overlapping requirements. So another part of the recommended settings is you'll see here's recommended for PRC 24, recommended for PRC 29, recommended for IEEE 2800. If the whole purpose here for many of these settings are maximizing them, why are we delineating these things? Here's your maximum. And I'm having overlapping ride-through requirements. I know this is happening on sites where IEEE 2800 is adopted. And then if it's NERC site, you need to have both. And they aren't exactly the same. So I need plans for overlapping of these requirements. And in my view, there's a lot of cases that they're not actually separate, they're not different. They're different requirements, but the approach is the same. And the recommendations have been the maximum. Document management is a really big thing that I would like to see recommendations being used here. So I see from also what the standard drafting team is doing, we're making updates to what we need to know about hardware limitations. The standards are updating. We're seeing clarification. We don't want to have to like redistribute all these documents over and over again, have every single developer and OEM and developer and owner asking OEMs, hey, send this, send this, send this. And in the end, in order to address all of the bullets, we're like Frankensteining these emails and documents together. Let's work towards document repositories where we have a document that can be distributed easily to the people who need it, and more of like a one-stop shop situation. This also applies to your models. New model revisions come out, we need to know about it. We don't want to have to ask every single time, and we need to know how these things are evolving. Documents need revision histories that explain the changes and flag those that introduce lesser performance, especially because those are going to come up as questions like, why did we think the voltage write-through was going to be this, but now it's this? Explaining that is incredibly useful for everyone's understanding, and we do need those documents to be tracked. I don't know how OEMs could do this with NDAs and things like that, but I think this method I see most having is the email response, email response, email response, email response, email response is a massive amount of just administrative time that can be definitely avoided. Address all hardware and software deviations that exist in a product in a clear way, such as buffer additions, ZVRT add-ons, and things like that. We don't need every customer and every site to have its own document necessarily. We just need to be able to say, okay, this one has a 16 kilojoule buffer, it has this software, here's the related item to it. And as owners and developers, we should know what we have, or we should work with the manufacturer to know what we have. It's a lot of burden on OEMs to expect every single site, all of that. And I think we introduce human error as well when we're starting to do documentation in this piecemeal way. We need information on hardware limiting equipment, and definitely OEMs need to be tracking the -2 version of the standard so that they can update their documentation with what is required, and please be able to broadly distribute it to your lists that have NDAs. The other big item that I see is we need to streamline our setting updates and setting documentation. There's going to be a lot of updates to settings. If people have done this correctly, there's going to be a lot of updates to settings over the next couple months. And I don't think any of us want to run into resource constraints right before we need to make changes. There's going to be a lot of setting updates in the next year. Document how you plan to do that with customers and start doing it in a consistent way. All right, for developers, there is a bit of difference between those that are in operations and those that are in development. The first thing is get documentation from OEMs. And if you haven't started your Frankensteins now, start your Frankenstein documentation. So OEMs on the call, I would like to not have Frankensteins as my compliance evidence. Previous settings are unlikely to comply. Maximums are a must. So previous settings that were really designed for PRC 24 are not likely to comply. Just know that now. You're going to need the maximums. You're going to need to make updates. This is going to impact your relays. Your relays were probably designed to meet PRC 24 and to be outside the previous settings. Settings move out, relays here. have to also visit your high voltage and your protection systems. Prepare for hardware limitations for legacy units. I think I also saw questions in Slido about legacy units and where the manufacturer is out of business. I think a lot of folks gave comments to the standard drafting team on version 1 about that. I think none of that quite made it in. So definitely just plan for that. Prepare for setting updates and lead times. So everybody's going to be asking manufacturers to help them change settings if they do not have access on their own to do it. It all depends on access to your site, firewalls, what you have set up, accessibility to the ride-through settings. But everyone's going to be getting in line. So plan to get in line to those OEMs that need to support you in making changes. Development, ensure new sites are planned for PRC 29. Update your contracts, make sure your EPCs are on board, make sure your protection systems are going to be designed for this. And track -2, that's going to be important. So what does this all boil down to, and what are we going to be seeing soon? Remember, we'll have the hardware limitations. Basically, you're supposed to like scream from the rooftops to everybody, a lot of people, and they're going to review your hardware limitation. There will be other updates triggered by PRC 29. So to be ready for this, your models have VRT and FRT as lines in them. Those will need to change and be resubmitted. Other reports you may want to revisit like PRC 19, modeling reports. This is not a standard that is alone. Everything is pretty impacted by it. And then keep in mind that we have PRC 28 reporting and a shift in the industry to more like, look, an event happens, check for PRC 29 ride through. That's the performance moment for all of us. And I think it's going to be pretty interesting to see it play out. So to recap, events that led to PRC 29, some public service announcements, there were some big changes. I have talked about OEM capabilities, how the settings and documentation are going for most OEMs, and tips and recommendations, as well as where we're going next. From there, I think we'll go to Julia on the agenda, probably open questions.
All right, thanks so much, Katie, and thanks everyone. I think it's really good lineup of presentations. We have 18 minutes left for questions. I'll first go for questions that didn't get any reply in Slido, just to get a reply, and then maybe we'll hit some of those that have a reply in Slido just to voice it out. So the first question without a reply was about if IBRs are connecting to 525 kV systems. There are some concerns about meeting upper voltage thresholds. These levels exceed 550